Hi friends, welcome to our channel Knowledge Rain. Today we are going to discuss about enzymes as food processing aids, or the enzymes which are used in food industry, or just simply the food enzymes. First of all, what is enzyme? Enzymes are proteins produced by living organisms to increase the rate of immense and diverse set of chemical reactions which is required for life. The term enzyme is derived from the Latin word meaning in yeast. Simply, the enzymes are highly specific biological catalyst. The enzymes are highly specific biological catalyst. The term enzyme was coined by the German physiologist William Kane. William Kane is the German physiologist who coined the term enzyme. And based on the type of chemical reaction they catalyze, the enzymes are generally classified into 6 groups. They are oxidoreductases, transferases, then hydrolases, then lyases, isomerases, and ligases. First one is oxidoreductases, and these enzymes catalyze oxidation and reduction reactions. That is, they catalyze oxidation reduction reactions where electrons are transferred. Then coming to transferases, these are enzymes which catalyze the transfer of a chemical group from one compound to another. That is, they catalyze group transfer reactions. Then coming to hydrolases. Hydrolases are enzymes which catalyze the hydrolysis of bond. That is, they catalyze reactions which involve hydrolysis, that is the transfer of functional group into the water. An example is the breaking of peptide bonds by the enzyme pepsin. Pepsin which hydrolyzes the peptide bonds in protein. Then lyases. Lyases are enzymes. By the action of these enzymes, the functional group are either added or removed. That is, if the functional group is added to break the double bonds, or the double bonds are formed by removal of these functional groups. This is the action of lyases enzymes. Then isomerases. They catalyze reactions for the formation of an isomer compound. That is, they catalyze reactions that transfer functional group within a molecule. If functional group from one compound is added to the other compound, it is transferase reaction, while the functional group is transferred within a molecule so that the isomeric forms are formed. That type of enzyme is isomerases enzyme. Then ligases. Ligases enzyme catalyze the joining of two molecules. That is, they are used in catalysis where two substrates are ligated. And the formation of carbon sulfate due to condensation reactions. That is, due to condensation reactions, carbon or carbon sulfate bonds are formed, which results in the catalysis or the ligation of two compounds. And this is about the classification of enzymes. Enzymes, using the enzymes in food processing, that is, food processing through the use of biological catalyst or enzymes, is historically a well-established approach. The examples include brewing of beer, bread baking, then cheese and wine making, etc. Enzymes have always been important to food industry because of their ability to act as catalysts, transforming raw material into improved food products, etc. We already discussed about the classification of enzymes. The enzymes are generally classified into 6 classes: oxidoreductases, transferases, hydrolases, lyases, ligases, and then isomerases. Among all these classes of enzyme, they all have a application within the food and feed area. But hydrolysis is the enzyme which is more prominently used in food industry. Then now we can see the application of enzymes in food industry one by one. First one is the dairy industry. In dairy industry, chymosin, lipases, then lysozymes are used in cheese manufacturing, then lactases or beta galactoxidases, which helps in the breaking of lactose into glucose and thus reducing lactose intolerance reduction in people. And this lactose or beta galactosidase is used as a prebiotic food ingredient. Then lactoperoxidase helps in cold sterilization of milk. Then acid proteinases helps in milk coagulation. Neutral proteinases and peptidases helps in accelerating cheese ripening, debittering. Then the production of hypoallergenic milk-based foods. The lipases, we already discussed about lipases used in cheese manufacturing, especially lipase helps in a cheese flavor development, that is cheddar cheese production. Then coming to baking industry, the most commonly used enzymes in baking industries are alpha amylase, beta silonases, then oxidoreductase, lipases, proteases, etc. And the alpha amylases, which helps in baking, that is starch liquefaction, bread quality improvement, etc. Then that is the increasing the volume and crumb structure of bread. Then lipases improves the stability of gas cells in dough. Then proteases, which helps reducing the protein in flour, that is it helps in bread quality improvement. Then coming to juice industry, amylases, glucoamylases, pectinases, cellulase, hemicellulase, lactase, and narignases and limonase are used in juice industry. The role of amylase and glucoamylase breaking down the starch into glucose and clarification of the juices. Pectinase is also having a similar role, that is a clarification of the juice. Then cellulase and hemicellulase along with the pectinase helps in lowering viscosity and maintaining the texture of the juices. Then lactase helps in increasing the susceptibility of browning during storage, that is it helps in removing the polyphenol removal from wine. Lactase helps in the removal of polyphenol compounds. Then narignases, it is an enzyme which increases the wine aroma enhancement. Then it is also a debittering enzyme in citrus juice. Narignases and limonases is used as a debittering enzyme. Then coming to starch processing. The enzymes used in starch processing include alpha amylases, pullurenases, beta amylases, glucoamylases, isoamylases, glucose isomerases, and glycosyl transferases, and neopullurenases, amylopullurenases, etc. And the most commonly used or the industrial degradation of starch is usually initiated by the alpha amylase, and which cleaves at the 1,4-alpha 1,4 glycosidic bonds, and together with this alpha amylase pullinases also act, and the pullinase is again divided into type 1 and type 2. That is type 1, it exclusively hydrolyze the alpha 1,6 linkage and produce branched dextrins. And type 2 hydrolyzed both alpha 1,4 and alpha 1,6 linkage and mainly produced maltose and maltoxylase. And the three basic steps in enzymatic conversion of starch, which include gelatinization, liquefaction, and saccharification. And the two types of exoactin hydrolysis commonly used in starch saccharification is beta amylases. Beta amylases and glucoamylases, they are used in saccharification process. Then coming to brewing industries, the most commonly used enzymes are alpha amylases, then beta glucanases, pullinases, then amyloglucoxidases, proteases, pentosanins, silosanins, and alpha acetolactate decarboxylases or ALDC. Alpha amylase mainly helps in hydrolyzing starch to reduce the viscosity and liquefying agent, thereby increasing maltose and glucose content. This is the role of alpha amylase. And coming to beta glucanases, they hydrolyze glucans into oligomers and leading to lower viscosity and better filterability and improving wort separation. And then coming to polyonases, and we already said that it hydrolyzes at the alpha 1,6 branch points of starch, securing maximum fermentability of the wort. Then amyloglucosidase, it increases the glucose content, increasing 1% fermentable sugar in light beer. Then proteases, it increases the soluble protein and free amino nitrogen, that is FAN. Proteases increases the soluble protein and free amino nitrogen, thereby helps in the malt improvement and improving yeast growth. Then pentosanins and salicylins, which hydrolyze pentosans of malt, barley and wheat, improving extraction and beer filtration. Then coming to ALDC, that is alpha acetolactate decarboxylases, which helps in converting alpha acetolactate to acetoin directly, decreasing fermentation time by avoiding formation of diacetyl, making beer taste right. The beer and wine are both alcoholic beverages produced by yeast fermentation of sugars, and beer is the world's most widely consumed alcoholic beverage, and it is the third most important or popular drink after water and tea. Wine is based on grapes and beer is traditionally based on barley. And this is about the brewing industry. Then coming to meat processing. The main important enzymes used in meat processing include acid protease, which helps in improving flavor, nutritional and functional properties of proteins, and it converts the animal carcasses into flavorous compound under mild conditions without any byproduct formation. Then coming to tyrosinase, it helps in cross-linked meat protein, then enhances the functional properties of enzymes. Then glutaminase, it enhances flavor of meat protein due to L-glutamic acid. Then elastinase, this helps in tenderize meat, improve the commercial value of low value meat. Then the enzymes, papain, physin, bromelain. They are extracted from papaya, fig fruit, and pineapple. These enzymes are proteases which helps in meat tenderization. That is, it hydrolyzes both animal and plant protein, increase the protein dispersibility, then palatability, solubility, and digestibility. Then transglutaminase. These enzymes improve the structural properties of processed or cooked meat. The lipases, it hydrolyzes triglycerides and improves the flavor in sausages. And actidine is an enzyme which improves the tenderness in processed meat. And this is all about the use of enzymes in food industry. And thank you for listening this video. And if you like this video, give us a thumbs up. Please subscribe our channel, share this with your friends, and leave your valuable comments.